Our first presenter will give a talk on enriching scientific and interactive computing with the project SCINCO, JupyterHub, and Kubernetes. Go ahead, Anagha.
Thank you, Louis. Hi, everyone. I am Anagha Jamthe. I'm from Texas Advanced Computing Center. And today I'm going to present our work on enriching scientific and interactive computing, the project SCINCO, which is JupyterHub on Kubernetes, on behalf of my colleagues, Joe Stubbs, Mike Packard, Joon, Chuah, Julia, Looney, Gilbert, Curbelo, and Cody Hema. We all know that there are several challenges involved in scientific computing, right from gathering data from different instruments and sensors, storing the data, processing it, running simulations on the data, sharing and publishing your results with the scientific community. We need the right tools to do these tasks in a fairly easy and reproducible way. Scientific Interactive Computing Project, known as a SCINCO project, provides a hardened production-grade Jupyter Notebook as a Service platform, which is capable of utilizing advanced computing and storage resources. With SCINCO, you can perform a range of computational tasks in real time, including the data cleansing, analysis, visualization, and post-processing. SCINCO is a scalable interactive computing platform that leverages open source container technology such as Kubernetes and also uses a customizable JupyterHub. Launched in 2020, SCINCO builds upon a custom JupyterHub offering developed at TAC since 2015. Since then, there are more than 1,600 users that are running across 5 different clusters at TAC. Here are a few of the examples of the projects that use SCINCO. First one is the Design Safe portal, which is used for natural hazards research engineering. ECHO, which is the estimating the circulation and climate of ocean. And HEDEX, which is used for Hubble-Eberly telescope for dark energy experiment. SCINCO is also used as teaching tool in several workshops and trainings. It has also been used in different engineering, computer science, and physics courses. To explain the scientific impact of SCINCO, let's consider an example of Hubble-Eberly telescope dark energy experiment, which is also known as the HEDEX project. HEDEX is the first major experiment to search for dark energy. It uses the giant Hubble-Eberly telescope at McDonald Observatory and a set of spectrographs to map the 3D dimensional positions of millions of galaxies. HEDEX leverages SCINCO for visualization and interactive analysis. The project has about 50 plus SCINCO users team led by Dr. Erin Cooper, who is the data manager of the HEDEX project. About half of these users are students who classify galaxies, and rest of the team works on accessing data and visualizing it. This team has developed several widgets to interact and interpret the data. SCINCO offers them a quick and easy way to fairly access the complex data model that they use. In a press research published on December 2020, the team mentions that how tax resources have accelerated their data analysis and visualization for this project. We also have included a data cube scanning video that's done on JupyterHub, which I can refer to after my presentation. So SCINCO is a JupyterHub running on Kubernetes. But what exactly is JupyterHub? So JupyterHub is an open source cloud-based version of Jupyter, which allows many users to remotely access their notebooks and files. SCINCO inherits several benefits from Kubernetes, such as scalability, reproducibility, portability, and at the same time, it reduces the administrative overhead that is associated with managing several servers. You can easily isolate different projects from each other using namespaces. With Kubernetes, you can achieve greater computational power with better load balancing using just a couple of bare metal physical servers. SCINCO also uses customizable JupyterHub. This is the architecture of SCINCO, where you can see that the green blocks are the ones that are modified by TAC and the red ones are community provided. So the hub manages authentication, user accounts, and coordinates the single user notebook server spawning, whereas the authenticator leverages TAG's OAuth server. So every user in TAG is assigned a unique ID in order to access TAG's system. And they're also put into specific groups called as the GIDs. Once the user authenticates with the JupyterHub using either a GID or a UID, the spawner spawns notebooks for them. The community provided Kube spawner is modified to customize how the user notebooks can be launched on the cluster. The spawner class makes an API call to TAG's accounting system and looks up at the user's unique ID, UID, and GID. This determines at the time of launching the notebook which volumes the user has access to. Kube spawner, as you see, also uses the Tabis metadata service in order to customize the configurations for volume mounts, notebook images, memory limits, CPU, etc. for each project. Another cool feature of SCINCO is the admin portal, which was released recently in fall 2021. With the admin portal, the administrators can manage and apply configurations that we mentioned in the previous slide, such as the volume mounts, CPU, memory limits, etc. They can add and remove users for the project. They can see how many notebook servers are running, how many resources they are consuming, and so on. They can also stop the individual notebook servers if they see that the CPU limits for certain user pods are exceeding beyond a certain threshold. Similarly, they can add or remove volume mounts images for specific users. Here is an example, like screenshot from the JupyterHub admin portal that is deployed in our production environment. As you can see that the administrators have control on modifying the user group's volume mounts images. They can see the list of users that are currently active or inactive on the JupyterHub, and they can also see the timestamp when their user pods were started and when was the last activity on their notebook server. We've also developed a dashboard for reporting usage metrics with Grafana. So Grafana is basically a graphing and visualization application which can query different data sources such as Prometheus, Elasticsearch, MySQL, etc. In this example, the Grafana is querying Prometheus, which polls an exporter on the Kubernetes compute node to provide data. As we already discussed that the projects are isolated by the namespaces, we are querying the design safe JupyterHub prod here, and these were the active number of pods. Like there were the 105 user pods running on that environment. You can also see when was the first time that the user pod was launched in the last 2 years. You can calculate new users based on several queries that we can build in. You can also see the number of daily containers that are launched on the Designs of JupyterHub pod. You can see how many sessions are created by each user. Similarly, this dashboard is really useful in calculating the real-time CPU usage per container, memory usage, network I/O, disk I/O, and so on. So this feature really helps the administrators to generate reports either daily, weekly, yearly, as alike. Thank you for patiently listening to my presentation. If you have questions on adopting SCINCO for your projects, please reach out to us on this email address, and I'll be happy to take any questions you have.
Thank you, Anagha. Do we have any question? Just one quick question.
Anagha, are you using like actually the chat stream or like your tag, computer resource? Mm-hmm. Which resource are you using right now for the Kubernetes, management?
Yeah, we're using tag resources right now.
Oh, okay, got it. Is it possible to deploy, your like a system into the chat stream as well, I guess?
Yeah, I think it is quite possible to do that.
Oh, okay. Thanks.
Mm-hmm.
Thank you, Anagha.
Yeah, thank you.
We will continue with the second presentation. Is Alex Rocha here?
Yes, I am.
Okay, are you ready?
Sure am.
Okay, Alex will be presenting deploying configurable and containerized science gateways. Please go ahead.
All right. Thank you for joining me. I'll be talking about deploying a containerized science gateways attack along with my co-authors, Sal Tijerina and Nathan Franklin. So the background here is we were trying to basically upgrade and change the deployment process from deploying services directly to VM using Ansible and Jenkins. Ansible has been great for provisioning VMs, but when it comes to upgrading, rolling back changes, and especially with VMs needing to be upgraded, it led to brittle deployments at times. So we wanted to modernize our deployment strategy and make deployments more reproducible, highly configurable, and scalable. First of all, reproducibility. So we wanted to be able to make sure that every commit to a main branch was built and published to Docker Hub. That's something we can do now. So previously we weren't running Docker images or containers for our services. Now we are every commit that's pushed to main is actually built and published to Docker Hub and can be pulled down by anyone to run locally, as well as in production or other environment. We are able to lock packages down with a lock file in both NPM and Python, and we use Docker image tags, and gateway customizations are tracked in GitHub for full release provenance. So configurability, we wanted to go ahead and be able to separate our DevOps process from our service code. So previously we had DevOps code living right next to like our service code. So for a gateway, and for better deployment process and for to separate those concerns, we wanted to make sure and split those up. We managed to do it now. We've simplified our environment-specific configurations. We track changes and allow for quick manual rollback of those changes, especially with Docker images being published to Docker Hub. It's quick and simple to roll those back. And we wanted to allow for any combination of deployed services with little to no infrastructure changes. So basically just configuration to allow a custom suite of services for any gateway. And scalability. So now a single VM can host one or more portals instead of with an Ansible approach where everything was deployed to one VM natively. One VM can now be used to host a number of gateways, whether they are on different domains or not. We can still spin up through text VM farm new VMs or additional capacity if that's needed. We also have developed a good process that helps with provisioning VMs and how to deploy these gateways. So how do we do our container and service management now? We've developed a repository called Camino. That repo is basically how we track and manage Science Gateways deployments. It is a configuration repo that maintains a version of a project deployed in each environment, and we're able to both commit changes as a tag that points to a specific Docker Hub image to deploy upgrades or rollback changes. Camino, which is our codified version of Docker Compose configuration, manages all of those changes, and it also manages service communication. Our workflow is pretty straightforward in that we for at least for our core portal, we have other services. For example, for the core portal, we store all of our code in a repo, and we trigger a job through Jenkins that reads the configuration from Camino, and then deploys to the portal, the gateway instances as configured in Camino. A few instances of those are, so these examples at the right, Design Safe, Neurnext, A2CPS, Protex, those are a few examples of the gateways that we have deployed using this deployment management system. Containerized gateway services. So here's an example of two real-life portals that are deploying the services that you see on left. Both Frontera and A2CPS are Science gateways that have a content management system, core portal, Nginx, Celery Workers, RabbitMQ, Redis, Memcache, a number of other services deployed in the VM, and each of them is an independent Docker image, which builds into a container and runs in both. And through Camino, we're able to configure these independently, and they can provide as much customization as we like. In addition to deploying the same services in different ways, we can also use Camino to deploy different services to each gateway. So for example, the Frontera portal has a user guide that A2CPS doesn't, and A2CPS has a custom visualization that Frontera doesn't. And we can do this and do this for a number of other portals. Here is an example of a search showcase. So most of our deployed gateways, though not all of them, have a content management system. And that is an actual image that's pulled down from Docker Hub and runs via Camino. And this is an example of what it would look like in Frontera. An A2CPS, it would look completely different because of the flexibility of this deployment system. And another thing that I can show you is the core portal. The core portal is also running under the same domain. This is the Frontera core portal, and it runs as an independent service. If we wanted to upgrade the core portal, for example, all we would have to do is commit the image tag of the deployed of the published image in Docker Hub and run the Nginx process, and this would be updated right away. So we wouldn't see any downtime to the content management system, to Nginx, to workers, RabbitMQ. It is a 2 or 3 second deployment process, and with little to no downtime to the core portal and no downtime to related services. For future work, we want to do a full automation of VM provisioning. Automated branch deploys would be amazing, and further atomization of gateway applications. So that means that we want to make sure that we can spread out all the features and make the gateways even more customizable. And of course, as always, improve database automation, make more backups. These are our repos. Check them out, screenshot them, and ready for any questions if you might have them.
Thank you, Alex. Any questions from the audience? If not, thank you again, Alex. Thank you for the presentation.
Welcome.
Okay. All right. Now we will go with the next presentation with Joon Chuah. Next presentation is about Tapi's UI, rapid deployment serverless science gateway built on the Tapi's API.
I should turn on my camera microphone.
Okay.
Okay. Hi, everybody. My name is Joon Chuah, and I'm with the Texas Advanced Computing Center, and I'm here to present Tapi's UI, which is a project that is based off of version 3 of our API services, which provide access to HPC resources. So a little bit of history. So Alex kind of covered some of the gateways that we already have deployed at TAC. They're based off of our core experience portal or CEP code base, which are hosted on containerized services and provide essentially business logic abstractions on top of Tapis so that we can serve scientific communities. Some of the scientific communities that have benefited from this are included.
Hello, this is Brenda.
Hey, Brenda, this is Dominic with Lee's Appliance.
Hi, how are you?
Hi.
How are you?
Oh, doing okay. Yeah. So what do you know? Are you at the house?
So I'm actually just finishing up. I don't have the greatest news.
Brenda,
Oh,
can you
uh-oh.
please?
Loud.
Wait, someone.
Noise.
Oh, you are muted.
Transmission and motor.
Ooh.
So
Okay, let me
I tried looking
check.
underneath, maybe see, something was loose. If the
Louis, you can mute her. Brenda, everyone
Loose.
does hear you.
Fine. The valve down there was fine. It's just coming.
There's a mute all button at the very bottom of the participants list.
Louis, you can
That to replace.
you can go into participants and click on her and mute her.
Mhm.
With the remaining labor and the price of the parts are pretty expensive. You'd be looking
Who
at
else is co-host? Louis, do you want me?
Whoa.
Mute all under
I mute everyone, but I need to give the presenter the.
So you can unmute the presenter. You want to give me co-host?
Can you all
Maybe?
hear me now? Can you hear me now? I just unmuted myself.
Yes, yes.
Yep.
Okay, I'm going to continue then. With respect to CEP, we do have a couple portals that are hosted SGCI projects that are based off of CEP. And they provide access via our version 2 APIs to resources at TAC, including resources such as HPC systems, our scheduler, the ability to launch jobs and applications, as well as files. So the architecture of CEP, as well as a number of portal projects or gateway projects, such as Hub Zero or Open On Demand, are that you have a browser client, and that browser client, whatever the user sees, whenever you perform some type of interaction, such as trying to upload a file or launching a job, will make a call to a backend. And that backend is going to be hosted either on a virtual machine or on some type of container server, such as Docker or Kubernetes. The backend will perform business logic as well as things like user session management, logins and logouts, apply business logic, and then further on make the calls either to the HPC resource through whatever mechanism, and in the case of CEP, through TAPIS, TAPIS version 2. TAPIS is essentially the agent for the HPC resources, performing things like application launches or file management. With respect to the CEP architecture, it does require hosting, and as well as, in addition to the deployments, maintenance of those backends, and that does require resources such as the hosting resources themselves, as well as software developers, human resources. So TAPIS version 3, which is something that debuted this summer, is essentially the next generation of our API services, and it provided the opportunity for us to explore the idea of serverless gateway interfaces. A lot of modern cloud providers, such as, for example, Google Cloud, support features that allow for effectively what we call serverless gateways or serverless portals. What that means is that TAPIS v3, first of all, provides flexible tenant provisioning. We can quickly deploy your own namespace for your gateway. That includes collections of your applications, as well as HPC resources and definitions and access to files, as well as authentications for your own specific LDAP. In addition, it also allows client-side authentication rather than server workflows. We can now issue a token directly to the client. That token is JWT, which is a Java Web Token. In addition to carrying a datagram, it's signed so that it can't be faked, and it's self-expiring. So the authentication token is no longer a record within TAPIS that must be manually managed. We can issue these JWT tokens freeform, and they can expire on their own without requiring a backend to manage that user session. And then finally, the TAPIS v3 permission model allows for more flexibility, which essentially reduces the need for service accounts to perform operations. And service accounts are usually, those operations are usually managed through a backend. So with respect to that, our TAPIS UI architecture now removes the backend, and we can serve a serverless browser client, which is only JavaScript files. It makes the call instead of to a container or a virtual machine. It calls the HPC API directly, and then that HPC API can then further on be the user agent for those HPC resources. Because of this flexible tenant provisioning, we now have tenants that are associated sites. For example, our partners, University of Hawaii at Hilo, they have their own tenants, and we can actually configure further associated sites. So, for example, if you wanted to, potentially deploy some type of on-demand cluster in the cloud, TAPIS could essentially be the control plane, and then the TAPIS UI browser client can provide access to the control plane. So I'm going to show you the TAPIS UI now, and this is a project that is hosted. It's currently deployed to GitHub in this particular instance. The interface allows me to log in. I'm going to log in as my account, and then I can view things such as the HPC resources that have access to my files, and this is actually a live files listing. And then I can look at applications and launch them, and these applications are, of course, records that point to how to run an HPC container on a specific execution environment like Docker or Singularity. Once I submit the job, I can view the running status of the job, as well as see such details, such as where the outputs are going to be located when the job finishes running, as well as any sort of messages from the job itself. Finally, if I log out, the client just forgets my Java Web Token, And there is no backend that I have to essentially log out or force a log out from. So it's important to note that this is essentially a scaled down interface. It's very much in alpha right now, but it is what we like to consider the reference user interface for Tapas. So therefore, it doesn't necessarily apply the types of abstractions that you would have for science gateways or business logic, but it does also mean that it's very easy to deploy. We like to think of it as a rapid deployment that doesn't require a software developer. All you would need is a Tapas tenant, which can be provisioned either at TAC or on premises with your HPC resources. And then you would fork this particular repo, configure it to point to the URL of your tenant, and then just run deploy. You don't have to have those resources. It can be served from GitHub pages, and it's effectively free. So this is our serverless interface. The major artifacts for it are, of course, the repo, which is an open source repo, so that if you wanted to fork it and customize it, you could, and including things like changing versions of the Tapas APIs. And then finally, we do have an underlying library, which is published on NPM. And that library provides open API spec-based bindings for Tapas. So based off of this TypeScript library, it provides those API calls, object bindings, and strong types, so that if you do have access to a web developer that doesn't want to work in our React client, they can deploy their own client or develop their own client using a different framework, such as Angular or Vue. So our future work is, of course, bringing it out of alpha. We're going to continue to develop the existing core service features and eventually provide the ability to manage and maintain records of objects on Tapas. For example, creating your own application records, managing system permissions, and even doing file sharing. And all of this should be able to be accomplished without requiring the need for management on an HPC resource or on a VM. And that means that you can now access your HPC resources without the need for direct API calls, either from the backend or programmatic calls. So I'll take any questions now.
Thank you, Joon. Any questions from the audience for Joon?
Okay.
Okay, thank you. Thank you, Jan. Our next speaker is Parinaz Barakhshan.
Yeah, this is here. Is it coming through okay?
Yes, we can see it.
Hello, everyone. It's a pleasure to be presenting here today. My name is Parinaz Barakhshan. I'm a PhD candidate and research assistant at University of Delaware, and I'm presenting on behalf of my colleagues that are enlisted here. Today's presentation is about Atom Portal that presents high precision atomic data and computation. Let me quickly introduce you to the team. It's an interdisciplinary research project, and we have people from physics and computer engineering departments. Now I'm going to introduce you to the problem and our approach towards it. In many applications ranging from studies of fundamental physics interactions to the development of future technologies, accurate atomic theory is required for the design and interpretation of experiments. Atomic theory is a theory of the nature of matter in which we are talking about elements, their electron states, and some important properties of those elements like matrix elements and polarizabilities, for example, which I'm going to explain later on about these terms. The fact is that experimental measurement of the properties of these elements is often infeasible, if not impossible. That's why we decided to create an online portal for high precision atomic data and computation to provide such information to a wide community of users. And here's the link to the first version of the website. That's now available to the public, and you can simply go there and try it for yourself. Let's take a look at some of the developed web pages and explain their functionality to get a better view of the project. This is the front view of the project. Version 1 of the portal provides information on properties like matrix elements, transition rates, scalar and dynamic polarizabilities. And in the other data section, we provide information about radiative lifetimes, branching ratios, hyperfine constants for atoms and ions that are listed here. I don't really expect you to know these properties. I just use this term so that you can get an idea of different properties that have been calculated and presented in this version of the website. However, I'm going to present two of these properties today, and I'm going to explain them. The first one is called matrix element. The matrix element property gives information about whether a transition from an initial to final state is possible, and if so, the strengths of that transition. When you land on this page, all the electron states of the element, which is in this case sodium, appear. You can simply click on a state to get all available matrix elements for this specific state. Each row indicates the initial state, which is the state you have selected, the final state, and the strengths of the transition that we call matrix element property. The user can then print the table or download the Excel file to get the table information. The other property is called polarizability, and it's a measure of how easily an electron cloud is distorted by an electric field. You can simply click on a state button, for example, in this case, 3s½ for sodium element, and see a dynamic polarizability plot for the state to be created. That's the one you see in the middle of the page. Then you can use either the sliders or plot tools to rescale the graph. You can also save the graph or download the data file used to plot the graph. We have created web pages for other properties of these elements as well that we won't go through them for the sake of keeping this presentation short, but the other web pages are following almost the same structure as well. Let's talk about what we have in mind to release in future versions. In future versions, atomic computational codes would be released. The other cool feature that would be added is in case of properties of elements that are not available on the website because they are rarely needed, for example, users would be able to request those properties to be computed for them. And such requests will invoke the needed computations on demand and notify the user when complete. Also, more elements and properties will be added to the website. In addition to that, we seek community input to guide future releases. And one of the reasons we are here today is to get feedback from Science Gateways community. Here's the link to provide feedback. If you have anything in mind that we can provide to you, so simply bring it up. Some of the implementation challenges that we can talk about we had was related to automating the web page creation. There are two main reasons we wanted to do the automation. First, we didn't want any manual changes to the data to happen. And second, we wanted to make the creation of web pages for all newly introduced elements as easy as possible, even for non-experts. So we wrote these Python scripts to read data from CSV formatted data files and created the related web pages. The next challenge was the display of the denominations for electron states, such as the one you can see on the screen, for which LaTeX inserts are generated. As I mentioned earlier, we are getting CSV files as data inputs. CSV files don't have formatting in them included. So we did a mapping between the states presented in CSV file and the LaTeX formula related to each state. The next challenge was creating plots for polarizability property. We had the specific demands like rescaling the graph, saving the graph, showing the mouse position on the graph while hovering over it, for which we took advantage of the bucket visualization package. Some of the lessons learned in this collaboration are we need to set the expectations early in the process, like discuss the roles and responsibilities, like who takes care of what. The next point is discuss the technologies that would be used in the project. What are the programming languages you're going to use? Is there any reason to use a database? What's the underneath architecture? The third one would be discussing what it would take to work together better to advance the shared goal, which tools to use for the sake of collaboration. And the one that I cannot emphasize this point enough, but is about automating the process whenever you can to remove repetitive tasks and save lots of time. And the last point is consider community feedback in design decisions for the purpose of making the project as user-friendly as possible, especially in case of multidisciplinary projects. That's all I had for today. Thanks for your patience and listening to me. And I've included the links for the portal and the link to provide feedback on the screen. If you have any questions, we still have a few minutes to discuss it.
Thank you, Parinaz.
You're welcome.
Do you have any question from the audience? Questions? Do we have some minutes for questions? I have one, Parinaz.
Sure.
How many people are involved in this project?
The people involved in this project are, here's the team actually.
And the ones related with the software development, all of them?
Not the development. For the development is just me and the other guy called Adam Mars. But for the computational part and then advising us, we have the three advisors on the top.
Okay, thank you.
You're welcome.
Any other question from the audience?
This is Carol from Purdue. I'm wondering how who's supporting it in terms of provide funding for the development and in long term.
It's the NSF funded project.
Okay.
Yeah.
So for how long do you have the funding?
For now, we have the funding for 3 years, but then I think they have other plans in order to maintain the project.
Okay, thank you.
Thank you.
You're welcome. I'm gonna stop sharing now. Thank you for having me.
Thank you very much. And we will go with the next presentation. Is Christopher Thompson here or his team?
Yes, I'm here.
Okay. We have still a couple minutes.
Okay. Do you want me to start or wait?
Let's wait a couple minutes and we will start. I want to start on the right time.
So maybe I'll have a follow-up question to Parinaz. That so sounds like this. I wonder if this is your first gateway development, and if so, did you feel like you were getting help from the Science Gateways community or Science Gateways Institute, or how did you go about the development?
Well, this is not part of Science Gateways, but we are here today just to get feedback from Science Gateway community, because we did the communication at some point and we were interested to know about what their feedback would be about it, because we have domain scientists who might be interested in such a project, and that's the main reason we are here today.
I see. Thank you.
You're welcome.
Okay, our next presentation will be given by Christopher Thompson. He will talk about the development of A-Rescue online task management. Go ahead, Christopher.
Oh, sorry, I was muted.
Oh yeah, we didn't hear you.
Sorry. So yeah, my name is Chris Thompson. With Purdue University. I'm going to be talking today about sort of a different kind of gateway, a smaller project. We often think about these gateways as these big public portals which people can bring in tons of users and go to. This is a smaller project where they wanted to create more of a private gateway system that could be that each research team could deploy a highly customized model and just for their particular team. So first of all, what is A-Rescue? Well, it's a traffic simulator for evacuation, like citywide evacuations from natural disasters like hurricanes. It models the entire city road network for a particular area. It can handle hundreds of thousands of vehicles simultaneously. Each vehicle has unique properties that are randomized based off of what they've learned from studying actual survey data from real evacuation events for how people tend to leave. Each vehicle has, a unique starting point within the city. It may be a residential area. They have an itinerary. Maybe they can't just leave. Maybe they have to go from a residential area to a business area to pick up a family member, and then they can leave the city. Each one has sort of a unique driving style, even like more aggressive, more how closely they will follow the other cars on the other. Also trying to evacuate the same route, like how aggressively they change lanes. And then also sort of things like evacuation urgency, as far as is this a person who, as soon as the warning gets sent out, do they go, or do they wait maybe and they don't leave until the second day? So it's a pretty big simulation as far to model as realistically as they can how an entire city would deal with the order to leave an area. And it has a time step of only a few seconds. Every vehicle's position is updated every couple of seconds across multiple simulated days. So there's quite a bit of data flowing around. So when I joined the collaboration as a research software engineer, trying to help them out with their grant goals, they had already been developing the simulation for a couple of years. It was running. They're using a third-party agent model framework that provides a GUI for starting and running the simulation and monitoring its output. But the problem is they were having issues with, they couldn't go from basically debug mode to release mode. They couldn't figure out how to package up all the dependencies and everything so that they could just have one executable. So they would have every user follow a big long process to install Eclipse and run it inside of the Eclipse IDE. Which is not really, they knew that couldn't be the end goal. They had to work on some other way to have a user interface. So for each simulation run, there's a lot of steps involved. After they manage to get Eclipse installed and get it running, you have to modify some of the values in configuration files, then start up this GUI, and then it has its own tree of things that you can change. And then you actually start the simulation, and because it's running on these desktop machines, it would take several minutes before you would even see it begin to load and do things. So it wasn't a great user experience. So when I joined to help them, some of the goals were, obviously they wanted to move to a better UI interface. Now the professor wanted all of it. He wanted to have a desktop application, a web application. He wanted to create mobile apps. He also they envision quite a wide range of potential users. There's their own follow-on grants where they want to use this to do further research of evacuations. They want to see they're trying to get other research teams interested in using this simulation, but they also envision a future where maybe like the evacuation personnel for a particular like a city might sit down, and like the sheriff's department might use it to plan out what roads they're gonna close to get people out the most efficiently. But there's quite a bit of customization that has to be done for each city. They can't just come up with a general purpose deployment. Each research team that's using it has to create their own baseline data to define all the road networks, like the speeds on each road, the background traffic. There's a bit of setup, but then once they get it set up, then they can run through as many different scenarios as they want quickly. Now, this particular professor wants to run it not on their desktop machines, but in their private server that he'd already purchased at the beginning of the grant, that's managed by their department IT. But unfortunately, they have no admin access. So any solution we come up with needs to be able to run basically in user mode. Like we can't install anything that has elevated privileges. So first, to try to get ourselves away from this UI and Eclipse, we looked into the framework's documentation, and we discovered that there's a GUI-less batch mode that will package the model and all of its dependencies up into one Java jar file, submit it over SSH, run it, and copy the output back. It's a nice solution, but it's still being run inside basically as a wizard dialog box inside Eclipse. But we thought, what if we could take that jar and just build our own API middleware around it? We'd have to be able to communicate with as many different clients as possible, because the professor eventually wants a desktop application, a web application, mobile, all of those. We need to juggle all of these various input file formats and everything around, and separate them out into things that are fixed output, that fixed inputs that are created by each group once, versus the actual like individual scenario that's changing with each run, and orchestrate all of that so that we could just get a simple API that would talk to all of these different clients. We investigated several different solutions, but what we came up with was Node.js was the best. It's written in JavaScript, which the researchers already knew from their first attempts to make a prototype website. It allowed us to rapidly develop things, and we didn't need any sort of elevated privileges. It can run, the node runtime can be installed, in one directory. It can run from anywhere with no special privileges. So we could create a script that would set up this gateway once for any user in one location. And also, because the model itself is written in Java and Node is written in JavaScript, it would have great data passing back and forth between the two through JSON objects. So it's a pretty simple design. There is the Node.js program sits on their server. It talks over a WebSocket to whatever client they have created, whether it's a website or an app or something. It has the jar file that is the full simulation that then manages each several copies of it and passes control messages back and forth and status updates. But it keeps everything, it manages everything remotely, so that the only connection for any client is just a WebSocket. So we were able to do this without changing very little about the actual simulation itself. Originally, we just had the control program run the simulation and just monitor its output, monitor its standard out and its output files. But eventually, we added a network component so that it could actually talk directly. So the user's client talks to the control program with the WebSocket, and then there's another socket that talks to the simulation internally inside the server. But so one of the things was it needed to be a tiny footprint that was portable and anybody could run it. And this Node.js solution, it only has 8 JavaScript files, and it's controlled through a make file. The research team, any research team that wants to use this and stand up their own instance, they just need to basically pick a couple of output directories and tell it where their copy of the model that they've tweaked sits. And then whenever it runs, it just creates a new copy of the model and runs the jar. So before we started, their method was anytime they had to make a change to the simulation, they would have to go through the whole process of developing it and then distributing to each user the actual code. Each user would have to start up Eclipse, update their code, update their project files, recompile, and run it through the IDE. And then after we went through this process, now the team can make their changes as they do before, but now they just package it into a jar, update the jar on the server, and then the user just connects and they use it, and they don't have to worry about anything about where it is, how it's running. There's nothing for them to manage. Something else we did I didn't talk about was the UI, the front end to it. Like I said, the team wants to envisions a lot of different clients being created in the future. We were able to bring in help from a different UI expert we have here at Purdue, Sean Rice, and he, in a very small amount of time, was able to look at their prototype interface and revamp it so that it actually displays the information they want to display and works really nice and has a nice professional look to it. So the formal collaboration period has ended. We're working on releasing the code now. Some future work is we would like to containerize it because it's so already self-contained and portable already. It should be a pretty good candidate to make it even easier for other groups that want to use it by just giving them a container image where they just have to set a couple of bind or volume points where they want to bring in their model code and say this is where you should write your files to. But so there's a lot of potential. Some of the things we got from this project was that there's a lot of potential small teams out there that maybe their grant's already underway and they didn't write in support for a research software engineer to help them do these things. They weren't thinking about going towards the method of using a gateway. But you can, with very little involvement, this collaboration was only 0.2 FTEs. You can bring in a lot of technology and a lot of ideas that they hadn't considered, and really help them reach their goals without a huge investment. But there's a lot of projects out there like that where they just they didn't think to get involved with computing departments early. Mm-hmm.
Can you wrap up?
Oh yeah, sorry. That's it. So our code's already out there. Mostly we're in the final steps of putting it out on GitHub, but that's it.
Thank you very much, Chris. If you have questions regarding this talk, please contact Chris directly. Now we will ask the next presenter, Alexander Mitchell, in order to present the last talk of this session. It will be towards reproducible research on cyber GISX with Elmoth and EasyBuild. Are you there, Alexander?
Yeah, I'm here.
Okay, Chris, can you unshare?
Yes. Sorry.
Hi, I'm Alex Michaels. Today I'm going to be talking about our work towards reproducible research on CyberGSX with LMOD and EasyBuild. So CyberGSX is a Jupyter-based science gateway targeted at the geosciences. The platform has users with varying degrees of programming and technical experience, everywhere from undergraduate students in geography to geospatial software developers. So this image here shows CyberGSX Hub, which houses a variety of notebooks, blogs, and communities that are connected to our platform. So for the last few years, our approach to providing users with a compute environment has been pretty simple. We just put everything in one container. So this diagram illustrates what that looks like. We have a variety of essentials, Jupyter and its associated packages and extensions, some geospatial software, and then kernels from Conda to give our users their compute environment. We also utilized a shared directory, but we only really held example notebooks and data that was too large to distribute individually. The result was that the image was quite large. So this is 7.66 gigabytes compressed and 22.4 uncompressed. But that's not the biggest issue we had. Our biggest issue was that any kind of update or upgrade to our compute environment led to a rebuild of some proportion of our software. This led to some wide-ranging and unexpected changes to software and Python package versions. So we tried to minimize this by splitting the container into two Docker images with one inheriting from the other, but some degree of this problem would always persist. The biggest issue here was that means we had to retest all of our example notebooks every release to make sure it was compatible with the new versions. Additionally, old versions of software are no longer available in the compute environment. In theory, we could have tried to make multiple versions of the container available, but that would be an issue because of the size of the containers, and it would also provide a technical barrier to users because the minute they open our gateway, they would be asked which version of the container they want to use, and they would have no idea what's going on. It would also mean that they would have to kill their container and reopen a different version of the container just to switch between versions of kernels, and we wanted to avoid both of those. Obviously, Binder is kind of a solution here. It's an amazing tool for creating and hosting live environments for users to interact with your code. It could alleviate some of the problems, but software is built at the time it is needed with Binder. So this increases startup time, and it introduces the possibility that some of the dependencies of the environment are no longer available or could have changed. And it also puts the onus of specifying and managing software installations on notebook developers, many of whom are domain scientists or even undergraduate students who aren't comfortable with that kind of responsibility. This led us to our new approach. And our new approach, we've been able to move the software responsible for providing user compute environments from the container to outside the container. This eliminates the stresses of large and growing image sizes while allowing us to easily manage and provide as many kinds of and versions of software as we see fit. So our new approach utilizes three excellent pieces of software: EasyBuild, which provides us with a simple method to install software and generates module files with us, which makes software management much easier. We tried writing our own install scripts and module files, but we found EasyBuild to be much simpler, and it already supports thousands of software packages. Plus, creating easy configs for unsupported software is relatively simple, and we're hoping that by contributing to the EasyBuild ecosystem, we can lower the barriers for geospatial computing and make our software stack more easily replicable outside of the gateway. Next is LMod. It's a modules management tool similar to environmental modules, which is commonly available on HPC. It allows users to easily manage their compute environment by loading and unloading versions of their software. And of course, Conda on top of all of this. So it builds the Python environment that provides users with kernels on top of the software environment provided by EasyBuild and LMod. So what do kernels look like in this new approach? The specifications, so the Conda environment, the environmental variables, modules, etc. for kernels are given by a JSON file and a script which runs before the kernel is started. And the kernel in this approach is made up of two core components, the executable for the notebook. So in our case, this is a Conda environment, and then a set of modules that we want to load to give the user their compute environment. We specify this using what we call a meta module, which is just a module that loads other modules because this simplifies and gives users a default compute environment. So what does updating our environment look like in this new approach? It's much simpler. We can install new versions of software and new kernels on the NFS that holds all of the software without affecting users, and we're ready to push the update. We simply edit some startup scripts to make the new configuration our default. So the old configuration is available and untouched by our software process. This gives us a lot of benefits. It allows for many versions of software to coexist, so users can easily switch between the new and old versions of our compute environment. The container size is drastically reduced. The container is now about 4 gigabytes, whereas it was about 22.5. Another big benefit is that all of the software and Python packages survive upgrades, so we don't have to rebuild, it just stays there. And it's much more flexible because this gives users the ability to mix and match, especially if they're advanced users. A big concern when we deployed this was user experience, but we've had this deployed for over a month on CyberJS and its sister platform, CyberJS Jupyter for Water, with minimal issues. The average user doesn't know anything has changed because for non-technical users, they simply open kernels and notebooks in the same way they always have. Accessing and managing the old versions of kernels adds a little bit of complexity. This is because as we release more and more versions of kernels, it's overwhelming to make them all available to users in the dropdown. So we've decided for now to provide the current versions of kernels, which always point to the latest release by default. And then we wrote a CyberJSX command line interface, which allows users to install versions of kernels with a single command. And then they just have to switch the notebook's kernel in the Jupyter UI. But we're doing a little bit more work to make that happen automatically in the background. As for future work, we know that there's going to be more user experience hurdles. So the CyberJSX command line interface for managing kernels is relatively simple, but we want everything to be taken care of automatically in the background because it will confuse some users. So we're currently exploring how to do that. And as we release more kernels and versions of software, we expect more user experience concerns to arise. We also have some scalability concerns. Currently, our software is available through NFS, and we haven't observed issues, but as the number of users grow, we might start to see them. And then we also want to look at availability of our software outside of the gateway. Ideally, we'd be able to make our software stack available outside of the gateway itself, but there's a little bit more work to achieve that. For example, we have CyberJS Compute, which allows users to submit jobs, usually Python code, to HPC. We'd love to be able to directly provide our software there. Here are my references, and are there any questions?
Thank you, Alex. We are exactly 2 o'clock. Is the plan for this session. So I will thank to all the speakers for this session, and I will invite you to the other room for the closing remarks and some discussions to end the conference Gateways 21. Okay, thank you very much, and I will see you in the other room.
Well, I think this is we are staying here. This is the same. It's the same. Yes, we are staying in this.
Oh,
room.
Sorry, I didn't know it.
No, it's the same.
Hello.
So we just put it in the table for every session so that people can click on the sessions they would like to attend. So thank you very much to the speakers and to you, Luis. Great job, interesting talks. So yeah, we are staying here. So I hope everyone enjoyed the Gateways conference. You just should have received an email. We have we ask for feedback for the conference for this format with, you know, the lightning talks, the panels, tutorials, how you liked it, what you would like to see maybe the next time. We are excited that we want to do at least one in-person event next year, so that we can do that, and we will continue to organize that. And I, of course, would like to thank the program committee members. They put a lot of work also into this to make it work, and the sponsors, the reviewers who additionally jumped in, because we were really positively surprised that we got so many abstract submissions. So we asked additional reviewers to help us out. And yeah, so any feedback you would like to talk maybe now about, or something you would like to mention, suggestions for keeping some discussions up. By the way, GatherTown is open still the whole day for the conference. So we put some wine bottles at the beach, and if you want to walk around or meet with people, yeah, you can do that in GatherTown. So there will be also more emails than in regard to the videos, because we aim at uploading them to the playlist. So the email includes already the playlist, but of course there was not time yet to work on the videos. They need to be cut down probably at the end, at the beginning a little bit with the discussion, and the recording started always very early. So yes, anyone would like to make comments?
Sandra, I just want to say I very much enjoy the virtual conference. I know there are always pluses and minuses of a virtual meeting like this, but I think that it allows us to participate in the conversation when we find a gap on the schedule. So just want to thank you and the organizing team for a great work. And I just want to say really enjoy the experience so far. So thank you.
Great, thanks. Any further comments? Or would you like to have a look maybe already at your email and look at the questions there?
Can I? Yeah. Can I make a request to, if at all possible, continue to support virtual, so that if you have the in-person, that we do it as hybrid. The major advantages, in my opinion, for virtual are that it supports participation and attendance for those folks who are not able to travel, either because they're worried about COVID or because they don't have the money to pay for travel. But I'd like to put in a vote that it also provides an opportunity to actually demonstrate our computer skills just in using the software applications that support virtual attendance at a conference. So I'd like to make a plea to continue supporting virtual in the form of hybrid, if and when the conference does go back to in-person. Thank you.
Yeah, we think about hybrid also. At the moment, our impression is still that hybrid sometimes there is, the virtual part is a little bit still the second-class citizen. that doesn't mean, so we are discussing maybe having several options for virtual and several options where it's maybe streaming, like for keynotes or something, which can be watched then virtually. But maybe some things are like hands-on sessions, or, you know, it might be not always the best solution to do it with hybrid, but that is still an open topic, definitely. So there are a lot of discussions going on. Any further comments? I'm only looking up, not that I told everyone to stay here and there's another Zoom URL and I mixed that up from, from the email. Let me look at that. But I think we are here in the right evaluation. Yeah, that is that email. Yeah, it shows the same URL. Yeah, good. So I didn't let someone wait in another Zoom room. I'm glad about that. Okay, so yes, Lee.
Well, if I can, there we go. I was just going to say that I did like the lightning talks. I liked the chance to see a lot of things kind of quickly. So I kind of like that format. It gives me a big perspective of what lots of people are doing. So I know 10 minutes is not very long to talk, but it at least gets people a chance to see your product.
Yeah, I think also 10 minutes is at least a start, the discussion thing. I know it's, you know, when we talked about lightning talks, there was also some, 3 minutes in other conferences, lightning talks. 3 minutes is really tough.
Yeah.
but I like the 10-minute slot also, and also especially with, to be honest, with a little bit of Zoom fatigue after 1.5 years, a little bit of, you know, more dynamics in the session really is helpful. So
another thing I guess I've seen other places do is if you have a couple lightning talks in a row, just reserve like 15 minutes at the end for general discussion instead of trying to do the discussion right in between them. Sometimes you can do everything at the end. Maybe have like 4 lightning talks and then a discussion period, and then 4 lightning talks and a discussion period. I don't know if that would generate more discussion or less discussion. I'm not sure. Somebody else had their hand raised, so I'll shut up now.
No, so good. I did see that also. So John had his hand raised. John, or did you take down your hand by accident, or you still would like to say something?
Oh, I've just become bashful.
No, come on.
The only comment I was going to make was that the lightning talks are very effective, but I found myself not writing notes fast enough because the speakers were running fast. And so it made me wonder about, you know, virtual conferences like this, what's the equivalent, you know, technology update for proceedings? Because there's a lot of good information that passed by, if only in slides, where URLs someone might want to look back up, or even, you know, 18 months down the road when I'm doing a different project and I go, oh yeah, so I remember so-and-so was doing that. How do I open the package and start looking again?
So there will be, all the recordings will be available in the playlist. So I know you probably don't want to watch again all the 10 minutes, but so
that's why I put my hand down. It's just, I said, well, we've got to record it, yeah.
No, but I think it's a good topic. So what we did this year was we put all abstracts on Zenodo. So you can at least also read what the authors provided for the reviewers. And so everything that was accepted is on Zenodo now, the abstracts. We could think about, and I mean, but since if you have a little bit of time still today, at the moment in Gathertown are also some of the recordings which could not do a live presentation, but you talk of course about the live presentation. So the other chance would be we could ask the authors to send the slides maybe and put them also additionally on Zenodo. That could be something we could do.
Yeah, can I endorse that? There are a good number of conferences that I attend where that's actually required. In other words, as part of participation and a part of presenting your talk, there's a requirement to make the slide presentation available to all attendees. So it's part and parcel of the conference. Certainly my slides will be available on our website, but the approach that some of these other workshops take is they literally make it a requirement.
Okay. So Kirk, you have your hand up?
Yes, since we're on the topic of lightning talks, and I totally agree with the comments so far, I found them very interesting and effective. I just want to share an idea from another conference that I recently attended that they have an interesting format. They actually asked everyone to present their lightning talks in 90 seconds, which was impossible, but, and they wanted all of us to pre-record our presentation, and then the organizers actually grouped them in different series, and because they were 90 seconds each, so they were able to play 4 or 5 of them streaming concurrently with the Zoom meeting. At the same time, they asked people to drop their questions in chat, and also the organizers pre-planned ahead of time what might be some possible discussion questions, and then immediately after 4 or 5 lightning talks, they sent us actually more than 4 or 5. They sent us to breakout rooms. And then they were using the questions and discussion from the chat and also some of their pre-planned topics to open up different discussion rooms, and then people just choose which room they want to go to. And for some reason, I found that particular format effective for that event. I learned a lot, and then there was just some organic conversation. It felt like immediately after the streaming of the lightning talks, I was able to engage with other interested participants on the same topic. So just an idea to throw out as a possible format to consider.
Yes, I mean, for example, last year, I think Perk did that also, that the main talk was 10 minutes, but you could submit something like a 20 minutes presentation or something. I like also that way, definitely. Yeah, they're a little bit maybe with matching around a couple of formats is probably a good idea, and playing around and what works well, because some things work differently for different communities. It's like, for example, the Slack channels. I know that we are not so active, for example, in science gateways with the Slack channel. In the US RSE, we do almost everything on Slack channel. So it's something we need to test out a kind of with each community. So I think how the feedback is there, how people feel about the different formats. So
I think you said the magic word, which is community.
Yeah.
Because the technology presents a lot of options, but different communities, either because of their personality or the discipline or the content, will find different answers.
Yeah. Yeah, and therefore, honestly, some things is like, we are open, as you have seen, to new formats, to try new things. And we are always glad when it goes well. I hope that the survey will show that people like this. And otherwise, it's also, then we made the experience, maybe this is not the format was our community likes so much. You know, that might be, that is also not a bad outcome, then it won't be repeated. You know? Like we had yesterday, it was when I asked the 1 Mentimeter question, like what kinds of different formats of presenting your work or what is really important for you at a conference. And at this conference, we had 4 panels, and panels was ranked at the last as priority. Even so, I had the impression in the panels themselves that they were very lively and active and that people still enjoyed it. But yeah, probably we learned from that we do fewer panels. So, any further feedback? Comments? So I've seen the comments with the chat. I hope that they are saved. I think that is, let me see. With the recording, that should be probably something that is in the configuration. I'm not a host at the moment. Louis, can you give me co-host or host that I can check that? I think it will be saved. Thank you. I do this now. So yeah, I will see. I hope we did that the chat is saved. It's one of the configurations. And I saved, at least for this session, which includes the lightning talks from before, I saved it now. So that should work out, at least for this session then. Yeah, and so yeah, with the closed caption, definitely we should also get that as standard in the recordings. I've seen that Shannon often reminded me, at least as a host, to do that. So I appreciate that. Okay. So I would say enjoy maybe, you know, a little bit gather town still. Interact with hopefully a couple of people, go to the beach or to the lounge. There's a little bar area at the end of the lounge. There's still the videos with the lightning talks, which didn't have the space in the program. The sponsor talks, the sponsors are videos are all around 3-4 minutes, so they really did a great job. Yeah. So thank you very much, everyone. Great participation. Looking forward to further connecting with you all. And see you hopefully at other events.
Sandra,
yeah.
A quick question. Is there a list of participants somewhere on the website where we can find and connect with people that we met after the conference? I should have checked the website a little bit further.
No, we didn't put up the list of participants. Let me...
I'd like to support Kirk's request. That's a wonderful request. Thank you, Kirk. It would be extremely helpful.
Yeah, it's a little bit also a privacy thing. Oh. So we wouldn't publish the emails, to say it like this. Names, yes, we can discuss that, but not emails.
Any information will be helpful. I've just thought that, you know, after the talks going so fast, I may want to email someone and say, you know, I'd like to hear more about something. So thank you.
So with the talks, I mean, you can look up the authors, of course, in Zenodo, because it's out there. But of course, there were also more participants who didn't have directly a presentation or something. So I totally
can I comment on that, please? Because as a medical doctor who has to deal with privacy for patients and whatnot, I understand all the concerns for privacy, and I certainly am. I'm obligated by law to respect the privacy concerns for patients, et cetera, et cetera. But it's a bit of a contradiction, in my opinion, to promote open source, open code, open data, open scholarly research. Presumably, we're all scholars who believe in and support and promote the open exchange of scholarly research. And in that regard, I do believe that we should maintain a point of contact for correspondence via some of the traditional standard means of communication, which traditionally has been email. So I do believe that every scholarly research report should have at least one means of contacting via email to the scholar who is promoting and publishing that work, that presentation. So I'm not sure I understand the necessity to hide from each other, to put it bluntly.
To put it bluntly, I don't think it's about hiding. This was more also about on the website there are email addresses. Then you have web crawlers who just get it, and you get more spam and all these things. So it's more not about hiding. It's more about being also concerned about the.
Well, any research scholar who supports open publishing of a research paper, is that paper going to be published with or without at least one email to be the primary corresponding contact for that published research paper? Or is this community suggesting that practice should be abandoned? I, for one, maintain my belief that any open, published scholarly research paper and communication should have at least one visible, available email for correspondence with the author or author group or institution that is supporting the publication of that scholarly research communication. So I
didn't
you know,
say anything
so,
against
Carl,
that.
I think
I didn't
that
say
was
anything
done.
against that. I just said in Zenodo there are the paper, the abstracts with authors, so you can get there the email addresses. I was only saying. So without
I think
that,
the question was about registrants rather than
Yeah.
authors. All the
Yeah.
authors provided their contact information.
Yeah.
Okay.
Exactly.
Okay.
Sandra?
Yes.
I think it was in 2016. If I was in my office, I could pull my folder, but in the pamphlet that was published, in the back of the pamphlet, there was a list of all registrants. So even if you met someone who wasn't presenting and you didn't happen to get a business card or something, you could go and you could look them up and contact them. So I wonder if we could do something like creating a list of everybody that had registered and just email that to the registrants. So it would be the equivalent of getting the pamphlet like we've gotten before with all the registrants.
Yeah, because the pamphlet, of course, that was, let's say, something in paper form. That is, of course, easy. Let's say I don't have any concerns there. But yeah, I like the idea that everyone who registered can get also a list of the registrants. I think, and also the opt-in suggestion for the next time for the registration. I like that, because I still would like people that they can opt in or opt out if they want their name on a website. I think that should, everyone should have the right to decide that. Yeah. But the suggestions are good. I think for opting in, yeah, I like that. Any further comments? Or included recorded content waiver. Yeah, I think we had that in the registration, John. So that,
Yeah.
yeah.
Just a reminder.
Yeah, that was definitely the registration. Okay. And yeah, stay tuned for announcements regarding Gateways 2022. So we will start to prepare for next year. After the conference is before the conference. So thank you, everyone. And also thanks again to all the people who made this the success, from authors to presenters to reviewers, sponsors, PC members, participants, and our logistic Naidi and Cindy.
Thank
All
you.
the volunteers, yeah.
Yeah.
Bye.
Bye.